Hello everyone, I am Srisha from CSE AML. Today's my topic is what are the main differences among common emitter, common base and common collector configurations. So introduction to BJT, a bipolar junction transistors configurations. So BJTs can be configured in three main ways that are common emitter, common base and common collector. Each configuration offers distinct voltage, current, and impedance characteristics that suit different applications. We can see in the figures given. So the first one is common base, second one is common collector, common base, and third one is common emitter and common collector. Understanding these differences is essential for designing and analyzing electronic circuits. So let us move on to the common emitter configuration. This emitter terminal is common to both input and output circuits, typically connected to ground. It provides high voltage and current gain, making it suitable for amplification purpose. The phase of the output signal is inverted and relative to the input signal in this configuration. Here we can see that common collector configuration and common emitter configuration and common base configuration. Next, moving to common base configuration, CB, it represented as CB, and the base terminal is common to both input and output circuits, serving as a reference point. It offers a low input impedance and a high output impedance, ideal for high frequency applications. The output signal in this configuration is in phase with the input signal. Next, moving on to common collector configuration. It is also known as emitter follower. The collector terminal is common to input and output. It provides a high input impedance and a low output impedance. It is useful for impedance matching. The output signal follows the input voltage with a slight voltage drop and there is no phase inversion. So let us compare the voltage gain comparison. The common emitter configuration typically provides the highest voltage gain among the three. The common base offers moderate voltage gain, often used at high frequencies. The common collector has a voltage gain close to unity, functioning mainly as a buffer. Current gain characteristics. The common emitter configuration provides a high current gain and also it makes suitable for amplification. The common base exhibits a current gain slightly less than unity. The common collector configuration has a current gain approximately equal to the transistor current gain. It's beta. It represented as beta. So input and output impedance. The common emitter has a modern input and output impedance, versatile for many applications. The common base has low input impedance and high output impedance, favoring RF and high frequency use. The common collector has high input impedance and low output impedance, ideal for impedance matching. So let us move on to the relationship of phase relationship of signals. Uh, in the common emitter, the output signal is exactly a straight angle 180 degrees with phase, input with phase. And in common base, the output signal is in phase with the input. In the common collector, the output follows the input voltage without any phase inversion. So there are some typical applications of each configuration. So let us move on to it. So common emitter is widely used in voltage amplifiers and switching circuits. And common base is preferred in RF and high frequency amplifiers. Common collector is commonly used as a buffer of voltage follower in various circuits. So let us move on to the summary of key differences which we have discussed in our previous slides. So there are three main collectors, that are common base, common collector, common base, and common emitter, common collector. So each configuration provides unique voltage, current, and impedance characteristics suited to specific applications. Understanding phase inversion and gain properties helps in selecting the appropriate configuration. Mastery of these differences is fundamental effective electronic circuit and analysis. Thank you.